recording. All right, let's practice. Number 1, multiplication table. I have from 2 all the way to 12. You're welcome to extend the table from 13, 12, 13, 14, all the way to 20, or even bigger numbers. So let's try this. What is 2 times 2? What is 3 times 3?
6.
What is 3 times 3? Yeah, it doesn't
9.
let me type. 9, yeah. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7,
49.
49, exactly. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. 11 times 11, anybody remember that?
121.
12 times 12, you can extend the table, all right? 13 times 13, 169. 14 times 14, 196, and so on and so on. Those numbers are on the diagonal of this multiplication table, and they are special. Why they are special? Because they are what? They are perfect squares, right? They are perfect squares. Those are perfect squares. And I need you to remember them. Actually, not just the 1 square all the way to 12 square. I need you to remember from 1 square all the way to 20 square. I'll leave this to you to complete later, okay? 1 square is 1, 2 squares is 4, 3 squares is 9, all the way to 20 square. And I need you please remember those numbers. Those numbers are very important, especially for the last chapter. All the previous chapters before chapter 6 are prepared for chapter 6. Chapter 6 is the most important chapter for Foundation 2. It's also the foundation for pre-cal and cal. So I want you to remember those numbers. Of course, we have the chance to see them again later. All right, so that's the first thing. And second thing is about distributive property. Well, before we practice, before we understand and practice this property, I wanna talk about a concept. I wanna talk about terms. You should take notes, guys, okay? You should take notes. If you look at the book is very heavy. It takes a very long time to really read the details in the book. But your class notes is a shorter version of the textbook. You do not have to spend tons of time to read a lot of information. And the information in the notes is enough for you to pass. Actually, you can actually get a good score if you practice enough. So the first concept I want to go over is called a term. What is a term? We do not have to worry about what is a term today. Actually, we do not have to worry about what's the formal definition of a term, the first 3 chapters, okay? We only need to learn today 2 types of terms. Okay, I use the circles to represent sets, a group of items. So the bigger circle is represents the set of terms. As I said, we don't have to worry about what is term at this point. but we need to know two subsets of the set of terms. Or we need to know two basic types of terms, okay? The first one, look like this. A times x. A here is a constant. In other words, A here is a number. The number could be positive, could be negative, could be zero, could be fraction, could be decimal, could be rational, could be irrational. So A here could be any real number. Can be any let me scroll down a little bit. Yeah, any real number. And this constant A is called the coefficient of the term. Okay, A here is called a coefficient. You are going to hear coefficient a lot. Anyone ever heard that mathematics is a language? It is a language, okay? Yeah, any language has its own terminology and grammar. Same with mathematics, same with algebra. Yeah, we are going to mention coefficient a lot. Coefficient is always a constant. Here, A represents the coefficient of the term. It is a number. It could be any real number. And the second part of this term is this x. It is a variable. Okay? Yeah, here I use x, but actually it could be y or z or t or u or w, any other letters. Yeah, most of the time I use x. So if you see a thing, it looks like that. Yeah, what it looks like? It has two parts multiplied together. It is a number multiplied with a variable. Yeah, whenever you see a number multiplied with a variable, and that thing is a term. Okay, it is a term. It is a term. For example, let me change the color, black. Let me write something and you can tell, okay? All right, so 3x is a term, term. It is a term. Yeah, it belongs to this type. It belongs to this type because it has two parts. It has two parts, coefficient and a variable. Okay, the number here is 3. 3 is the coefficient of the term. Yeah, every term has two parts, numerical part and a variable part. Numerical part and a variable part. 3 here is the numerical part. X here is the variable part. The numerical part is also called a coefficient. It's same with the concept of coefficient I mentioned here. So this is the term 3x. The coefficient of this term is 3. All right, guys, help me out. Is this thing a term? If it is a term, what is its coefficient and what is its variable part? You can type your answer in the chat. It is a negative x. Help me to determine, is a negative x a term? If it is a term, what is the coefficient? Yeah, sometimes I think you can unmute yourself and we can. No. Oh, actually, it is. Okay, it is. Yeah, thank you, Belle. Amanda? Yeah, I'm happy we are going over this. Yeah, so there's some confusion. Negative x is a term, guys. Yeah, why is a term? Because it is a number times a variable. Do you see that? It's pretty tricky, right? Yeah, now you see it. Now I believe you can see it. Negative x is -1 times x. So -1 times x, it has two parts. -1 is the coefficient. X is the variable. It belongs to this type of term, okay? Yeah, belong to that subset. Do you see it now? Okay, very good. And next, please help me to determine if this guy, a term, just one letter t, just one letter t. By the way, t is not a constant, it is a variable. Yeah, help me to determine, is that a term? Let me see, how do you respond? Yes, one. Yeah, thank you, Amanda. Exactly. Let me minimize this one. T is 1 times t. It is a term. The coefficient of the term is 1. The variable part of the term is t. Alright, guys? Next, the last one. 1/2w. Help me to determine, is 1/2w a term? If it is a term, what's the coefficient? What is the variable part? We will find the time to go over fractions. I know fraction is not your favorite, probably for most of students, but we will take time to learn fractions better, because when we solve equations, inequalities, and factor polynomials, we cannot avoid to handle fractions. Yeah, decimals I do not worry about, because you have a calculator. Calculator is good at, calculating decimals, but scientific calculator cannot do fractions well, so you would have to learn fractions. Yes, the coefficient is half. The variable part is w. Yeah, coefficient w is a variable. Very good, you guys, great, perfect, exactly. All those, let me just close this syllabus, just leave a one word file. Yeah, all those four expressions are terms, okay? Yeah, they actually belong to they are this type of terms, a constant times a variable. All right, that's that type. And another types of terms is called a constant term. What is a constant term? Simply put, a number, a single number, it is a term. For example, 5 is a term. 93 is a term. 1/3 is a term. -0.4 is a term. Yeah, those numbers, they are terms as well. They are constant terms. All right, they are constant terms. So when you see an expression and with a single number there, that number is a term. Okay, about the terms, we only need to, at this point, okay, at this point, we only need to know two basic types of terms. The first is a number times a variable. Yeah, look at this again to see if you are able to tell -x is a term with the coefficient -1, variable part x. You should be able to see now. And look at the t, you should be able to see that is a term as well with coefficient 1, variable part t. And the second type is the constant term. People tend to forget constants are also terms. But just know, don't overthink. It's pretty simple. Constant is a term, okay? Constant is a term. Zero, is a zero a term, by the way? Is zero a term? Is zero a number? I'll answer this question. Zero is a term, okay? Yeah, because it's a number, so it's a constant term. Also, you can see that as a number times a variable. So it could be one of the two, any one of the two subsets. Zero is a term, okay? Sometimes in chapter 5, you need to be able to identify zero is a term. Yes, very good, perfect. And after talking about terms, next thing I want to cover is like terms. I'm going to write down the definition, okay? Two or more terms are like terms if they have exactly the same variable parts. This is an important definition. What is like terms? What are like terms? It involves more than one term. Two or more terms are considered as like terms if one condition is satisfied. What condition? If their variable parts are identical, exactly the same, okay? For example, earlier I have those four terms here, right? I have 3x, I have a negative x, I have t, I have 1/2w. Among the four terms, based on the definition of like terms, are you able to identify which of them are like terms? Or do we have a like terms in the four terms?
Would it be the 3x and the negative x?
Exactly. Awesome. Perfect. Because those two terms have identical variable parts. Their coefficients are different, no problem. We don't care about the coefficients. We only care about their variable parts. As long as their variable parts are exactly the same, they are like terms. So 3x has a variable part x, negative x has variable part x, so they are like terms. Very good. If we have like terms in an expression, you know what we can do? We normally need to combine like terms. Those are very basic thing. Combine like terms. Combining like terms, yeah. The rule here is we combine. How do we understand combine here? Combine here actually means add, okay? Take the sum. We combine like terms by combining and here means adding their coefficients. If we have like terms, we are able to combine them or add them together. This is not odd. It's ADD, not ODD. Added together. Take the sum. How do we combine like terms? We combine their coefficients and keep the variable parts. Yeah, I hope you are paying attention. Those are so basic and important. Earlier, we have 3x and a negative x, right? We agree those two terms are like terms because they have exactly the same variable parts, x. Then when we see the two terms in an expression, we are able to combine them. Combine them means add them together. Add them together. So how do we add them together? Yeah, 3x is actually 3x plus negative x, right? Yeah, but plus negative, we don't really write plus negative, we'll just write 3x minus x. But you need to see, when you have 3x minus x, you need to see there are two terms there. There are two terms there. The expression is a sum of two terms. The first term, 3x. The second term, negative x. And how do we combine them? How do we add them together? We keep the variable part and combine their coefficients. The coefficient of the first term is 3. The coefficient of the second term is negative 1. We operate their coefficients and then keep the variable part. 3 minus 1 is 2. We have 2x. Does that make perfect sense? 3x minus x. Yeah, how do we understand 3x? How do we understand 3x? 3x is 3 x's added together. Okay? Yeah. And if we remove, minus x, if we remove 1x, then we have 2x left. So the result is 2x. Do you see that? It's pretty straightforward. Okay, awesome. Very good. Thank you for your response. Yeah. And we have related the problem to practice on the notes. Yeah, thank you. So we covered what is a term. Yeah, of course, we didn't give the formal definition of a general term. We only get to know two types, basic terms, a number times a variable and a constant term. And we also learned what is a like term, what are like terms, and how do we combine like terms. Here, remember earlier I have 95, 10, and maybe half. Yeah. I have a question here. Are they like terms? We agreed earlier they are also terms, right? They are constant terms. Yeah, they belong to this category, this subset. They are constant terms. In fact, all the constant terms are like terms. Of course, you can combine them. You just add them as numbers, right? Yeah, let me write it down. You should include that in your notes as well. All constant terms are like terms. It satisfies the definition as well, because those constant terms, they do not have a variable part. So in a sense, they have exactly the same variable part, right? Yeah, variable part is absent, so it's the same. So they are like terms. And you can combine them just by adding those numbers together. Constant terms are like terms. Yeah, we can combine them as usual, as like adding numbers together. Let me find related questions here. Okay, number 3. Do you see that? Number 3. Let me leave some space here. Identify like terms and combine them. Yeah. We are looking at number 3 on the worksheet of Unit 1. Number 3, identify like terms and combine them. We just covered what are like terms and how do we combine like terms. So here we are going to practice. We have a bunch of terms here, okay? Yeah, bunch of stuff here. Yeah, we can identify. How about let me add one more thing. Yeah, determine if they are terms, and then identify like terms, and then combine those like terms. All right, let's start from the first one. The first one, x. A term or not? What's the coefficient? Awesome. You guys great. Exactly. And the variable part is x, right? For sure. Yeah, variable part. Variable part is x. Exactly. Yeah. Very good. And we had a same one earlier. Negative x is also a term. Coefficient is a negative one. Yeah, if you still do not see it yet, feel free to email me. Negative x is a term. The coefficient of that term is a -1. It is -1 times x is a term. Yeah, let's look at those terms. Do we have other terms in the list that they are like terms of those two? Those two are like terms for sure, right? Because they have exactly the same variable parts. Besides those two, do we have any other terms that they are like terms with those two that we can combine? Yeah, let's go over to 10x here. I saw 10x, right? And I see what else? No more? And that's it, right? We have 3. Yeah, 10x, exactly. Perfect. Then, yeah, those 3 are like terms. Means we are able to combine them, right? Yeah, let's combine them. Again, combine like terms is to add those terms together. So basically, we have x plus -x plus 10x. Remember the rule of combining like terms? We combine like terms by combining their coefficient, right? Yeah. Let's see what's the coefficient of the first term. What's the coefficient of the second term? What's the coefficient of the third term? Combine those combine those coefficients and keep the variable part. In the parentheses, we have 1 minus 1 plus 10 and 10x. In fact, those two terms are opposites, right? Yeah, because they add up to 0. They add up to 0. Yeah, to help you understand combining like terms, I'm going to elaborate more in this part. Let's say we go to casino. The casino has those chips, right? And you're gonna go gamble, try your luck. So you're gonna purchase the chips, yeah, different colors. Yeah, I'm going to use C to represent chips. Yeah, I'm going to use C to represent a chip. If you got 3 chip, 1, look like that, 2, 3. Yeah. How are you gonna record the 3 chips you have using mathematics notation? If I add them together, you understand what's going on, right? You have 3 chips. And you might want to record the 3 chips this way. 3 times chips. You have 3 chips, correct? Or you can write that as, you understand 3 times, right? Because what if you have 30? Then you have to draw 30 of those chips. It's going to be very troublesome. So, and a more efficient way to record 3 chips is 3 times chip, right? Yeah. And remember, I use C to represent the chips. So here we have 3 times C. And we don't have to really keep this multiplication symbol. We can just remove it and then write that as 3C. So 3C means 3 chips. Okay, you have 3 chips. And let's say you go ahead, you're gonna go gamble, and you the first game you win 5 more chips, and then the next game you lost 2 chips, and then you win 11 chips, and then lose 1 chip, and then you get tired, you're gonna go home, right? On the way back, on the way out, you see $20 on the floor. You pick it up. Okay, so we are going to calculate your balance by the end of the day. You start from 3 chips. You win 5 chips, and you lost 2, and then you regain 3. You regain 11 chips, and then the last one you lost 1 chip, and on the way out, you pick up $20. Someone drop on the floor. You pick it up. You get $20 for free. Okay, so how do we calculate our profit by the end of the day? What's our balance? Do you see terms here? Yeah, let's use our mathematics brain. Do you guys see terms? Do we actually, have 1, 2, 3, 4, 5, 6 terms added together? Do you agree? Yeah, this expression to record our, loss and gain and loss. Yeah, actually give us an expression, and the expression, in fact, is the sum of 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 terms. And this is a term, coefficient 3, variable part C. This is another term, coefficient 5, variable part C. This coefficient 92, variable part C, coefficient 11, variable part C, and this is coefficient -1, variable part C, and the last term is a constant term. Okay, yeah, we are using our mathematical algebra knowledge to find our balance by the end of the day, right? We're gonna combine like terms. Yeah, obviously we have 5 like terms here. Yeah, the first 5 terms they are like terms because they have exactly the same variable part C. Then we can combine them, right? Yeah. By the rule of combining like terms, we just do the math we just calculate the coefficient. 3 plus 5 minus 2 plus 11 minus 1, and then keep C here. What do we have? That looks like 14, right? It's 11 minus 1. 11 minus 1 is 10, 15, 16. 8 minus 2, 6. 6 plus 10, 16. Yeah. So you're going to have 16 chips in your pocket when you finish the day. Okay. Can we combine 16C with 20 though? Could we combine 16C with 20? By the way, we could only combine like terms. We cannot combine terms if they are not like terms. No, you're right. Very good. Perfect. We can't, because 16C and 20, they are not like terms. So we are not able to combine them. Yeah, they are all form-wise, okay? Yeah. Form-wise, we are not able to combine them. We just leave them here. Yeah, that's already simplified. 16C plus 20. is the simplified form. You have 16 chips in your pocket and $20 in your pocket. Yeah. So another way to see this, yeah, how do you know? Yeah, in case you get confused at a certain point, I don't know how to combine like terms. You just see the variable as chips, okay? You start with 3 chips, you earn 5 the first game, so now you have 8. Next game you lost 2, you end up with 6 chips left. 6 chips plus the 11 chips you gain in the next game. Hold on. 6, 5, oh my gosh. Mom's brain. Oops. 15, of course. Yeah, 10, 15, 6. Oh my god, it is 16. What's wrong with me today? 3 plus 5 is 8 minus 2 is 6. 6 plus 11. 17 minus 1 is 16. I was right. So you start with 3 chips, then you get 5, 8 chips, then minus 2. You have 6 chips. Six chips plus 11 chips, you have 17 chips, and you lost one more, you have 16 chips. And then you pick up $20, so you have 16C plus 20. Oh, thank you, Amanda. And Ricky say 16. Different money types. Yeah, exactly. Yeah, you can understand that way for sure. Yeah. So the purpose I give you this example, casino example, is to show you combining like terms is pretty consistent with common sense. Really, yeah, like earlier here, this question, we combine x minus x plus 10x. You start with 1x and you lost the x, so you have nothing right now. And then you gain 10x. So you can always use the casino method to get it done. And it's pretty fun, right? Yeah. I would recommend that you use this casino method when you combining like terms. And yeah, let's go back number 3. We identify those 3 are like terms. Let's explore other types of terms. Let me use a color. Let me actually erase those. We're done with that. We're done with those 3. Let me use a red color. Let me pick 0.3y. Do we have a term that is a like term of 0.3y here? Do we have any other? No, I only see 2, those 2. Yep. Yeah, we don't know the value of the chip. Yeah, that's a good idea. So it's a variable, right? So the chip is a variable. And what's the difference between constant and a variable? Constant refer to a specific number. A constant is a specific number. The value doesn't change. It is half is half. Is 91 is 91. But the value of a variable is not certain. Depends on the circumstances or context, right? Yeah, depends on the problem. Yeah, sometimes the value of the variable is unknown. Yeah, here the value of the chip could be $10, could be $20. So it's a variable. Depends. You decide. It's a very good example to demonstrate how does terms and the like terms work. So here we have the y, right? Do you agree that 23y and 5y, those 2 terms are like terms that we are able to combine them? Let's combine them. 23y plus 5y. Yeah. So how do you combine them? Exactly. How do you combine 0.3y and 5y? You can see that y, you can see y as what? As a yellow banana. So here you can say, I ate 5 bananas and I'm still hungry. I ate another 0.3, 30% of the banana, part of the banana. So in total, I ate 5.3 yellow bananas. Yeah, you can give it the background and make it fun, right? Awesome. Thank you, Jill. Thank you, Ashley. Felina. Okay, keep going. T. Blue. 2T here. Do we have any other terms that could combine with T? What do you think about this guy? T square. Do you think they are like terms? Are we able to combine them? No, yeah, you're right. Thank you. Thank you, Ashley, Ricky. Yeah, Kara. You guys are awesome. Yeah, they are not like terms. They are not like terms. Yeah, but you know, they are so different, right? This one is twice of t, twice of t. And this is the square of t. Square of t actually is t times t. They are so different. They are so different. But in fact, is a common mistake that people confuse one with the other. They are not like terms. This term, verbal part, is just a t. This term, the verbal part is t square. Is t square. So they do not have exactly the same verbal part, so they are not like terms. Then we cannot combine them, okay? We cannot combine terms if they are not like terms. Keep going. Let me do this symbol, triangle, 10, 95, 0. Do you agree those are terms and they are like terms? What kind of terms they are? Yeah, we only learned today 2 basic types of terms. Yeah, what are they called? 2 words. Those numbers. They are constant terms, right? Yeah, 2 words. They are constant terms. 10 is a constant term. 95 is a constant term. Yeah, exactly. Constant terms. 0 is. So when we combine constant terms, we just add them together like numbers, right? 10 minus 5 is 5, 5 plus 0 is 5, and that's it. And keep going. What else do we have? Let's look at those two. Yeah, put them together in the same box, but look at it carefully. Look at it carefully. Are they like terms? Okay, by the way, those 2 terms are not one of the 2 types terms we learned today, all right? But they are terms. Yeah. Simply put, a term is an expression without addition and subtraction. So it's a bunch of numbers and variables multiplied together. So they are terms, by the way. Let me explain. Let me dissect them, okay? Yeah, let me break them down, the structure. So 3x squared y, the first one actually is 3x times x times y. Yeah, as I said, what is a term in general? What is a term in general? Bunch of numbers and variables multiplied together or divide, but you will not see add or subtract. So the first one is 3 times x times x times 3 times x times x times y. And this one instead is a negative 1 times x times y times y. Okay? And do they have, yeah, this term has coefficient 3. 3 is the coefficient. X times y, x squared y is the variable part. Yeah, this part is the variable part. And the second term, -1 is the coefficient. -1 is the coefficient. And the variable part is x times y, xy squared. They are different, right? Yeah. So the first look, and they are really very similar. But if you take the second look, they are different. They have different variable part. Yeah, the first variable part, first term, the variable part has two x's, one y. And this one has one x, two y's. So they are not like terms. Yeah. Let me know if you see it. They are not like terms. We are not able to combine them. Let me see if you, yeah, exactly. Thank you, Jill. They are not like terms. Are we good with that? Do you see that they are not like terms? Okay, thank you, Desiree. Awesome. Yeah, thank you, Belle. Thank you, Jill. What do we have? Oh, we have two more left. We have two more left. Those two. By the way, those two are terms as well. As I mentioned earlier, what is a term in general? Bunch of numbers and variables multiplied or divided together. Yeah. So those two are also terms. The first one can be written as 2 times x over y. And this one can be written as -1 times y over x. All right? Yeah. 2 is the coefficient. X over y is the variable part. -1 is the coefficient. Y over x is the variable part. Are they like terms? What is the yes for? Yes, they are? Are they like terms? No, they are not. They are not like terms, guys. Let's look at it carefully. This guy, this yellow one, as I break it down, has coefficient 2. Variable part is x over y. Numerator is x, denominator is y. Okay, numerator is x, denominator is y. And this guy, let me see, can I have another different color? Highlighter. And this one, when we break it down, we see the coefficient is -1. The variable part is y over x. Numerator is y, denominator is x. They're different, right? You see the yellow and the pink. They are not exactly the same. Yeah, oops, they are not exactly the same. Yeah, they are not like terms. Sometimes they could be very misleading or very tricky. It looks very similar, but they are not. All right, so I hope after we go over this question, we have a clear understanding about what are like terms and how do we combine like terms. Again, combine here means adding, added together. So num and then, so numerator and denominator needs to be, yes, Ricky. In order for the two terms to be like terms, their variable part has to be exactly the same. Let me explain why when you switch the numerator and denominator, you have a different thing. For example, 2 over 3. How do you understand 2 over 3? Let's say you have a pizza. You cut a pizza into 3 big slices. And 2 over 3 is 2 of the 3 slices. This big. That's how much pizza. How much pizza 2/3 represent. If we switch the numerator and the denominator, and we would have a different number. And different number 3 over 2. And how much pizza 3 over 2 represent? 3 over 2 is improper. It's actually 1 1/2. It represents 1 pizza I need more space. Let me see if I can. Yeah, one pizza and another half pizza. Another half pizza. They are very different, right? 2/3 is just a part of one pizza. 3/2, once you switch the numerator and denominator, you have one pizza and extra half pizza. So 2/3 definitely is different from 3/2. Then x over y should be different from y over x, right? Yeah, let me know, am I clear about that? I try to write my note more neat, kind of like a go upwards. Yes, okay, thank you, Ricky. Awesome, perfect. So it's a 46, we have 4 minutes. Now let's summarize what we have learned today. We learned terms, okay, 2 types of terms. The first 3 chapters, the first 3 chapters, we do not have to worry about the definition of a general term. We only deal with those 2 types of terms. We only need to know when we see them, we need to know they are terms. Yeah, the first type is a number times a variable. The number is called the coefficient, and the variable is called the variable part. It could use different letters. And the other type of terms are constant terms. All the constant terms are like terms. You can combine them, you can add them together. And like terms refer to 2 or more terms with identical variable parts. And you can actually see those variable parts as chips, right? Yeah, let's say you have, let me give you another example. Let me give you 5x cubed yz2. And another one is 93x cubed yz2. Yeah, so those are 2 terms. This term has coefficient 5, and this is the variable part. You don't have to worry about how complicated it is. It's just the variable, the whole thing, the whole pink is the variable part. And this is also a term. The coefficient is a -3. The variable part is the whole thing here. Yeah. So in order to determine are the 2 terms like terms or not, we only need to look at their variable parts. In this case, look at the 2 pink, parts. Are they identical? X cubed is actually x times x times x, and then times y. Z squared times z times z times 2z's. So the 2 pinks exactly the same, identical, right? So they are like terms. To make this simple, since they are like terms, we'll combine them. Sometimes I would say you just can see this pink as an apple, right? You have 5 apples here, and now you need I need to take 3 away from you. So you have 5 apples, and I take 3 apples from you. And how many apples do you have left? You have 2 apples, right? Does that make sense? Originally you have 5 apples, and I take 3 away. You have 2 apples. Yeah, it's just abstract. You know the difference between arithmetic you learn from like a very early age and algebra. Start from algebra, you start to deal with variables, and start from dealing with variables, you start to handle abstract stuff. So you can just see this abstract as apple. Yeah, the apple is, what is the apple? X cubed yz squared is your apple, right? Or you see that as a chip. You have 5 chips and you lost 3, you have 2 left. Yeah. All right, we ran out of time. Tomorrow I will update you with the new course material, and hopefully tomorrow we can have everybody properly register in Pearson. Then you can start your assignments. All right, guys, do you have any questions? Yeah, feel free to email me. Okay, awesome, very good. Do I have everybody's attendance reported today? Because attendance is so important, I don't want to miss anybody. Seems yes. Okay. All right, I'll see you on Wednesday. Have a good night. Bye bye.